Assalamualaikum.
Assalamualaikum.
How are you, Shavi?
I'm good.
I hope you are doing great and everything is going well.
Mm-hmm.
Okay, so are you ready for our today's lecture on S4 physics?
Yeah.
Okay, so have you prepared what we did in our demo lecture?
Yeah.
Okay, have you go through that PDF?
Uh, I'm pretty sure I did. My mum should have sent me it.
So have you reviewed that PDF or not?
Yes, just slightly.
Okay, so have you visited that website which I mentioned in that PDF?
No, I couldn't remember what the website was called, so
Okay, you can visit it later. Okay, you can visit it later.
yeah.
Okay, so let's start our today's lecture. Let me share my screen.
Alright.
Let me know that either you are going to school or preparing at your home.
Uh, sorry?
Are you going to school or preparing from home?
Uh, Preparing from home.
Okay, so you know no need to go to the school, right?
Oh no, I do go to school, yes, but uh, I do physics at home.
Okay, for physics only. Okay, sure. So, is it my screen is sharing?
Yeah.
Okay, right. Okay, so let's start in today's our first lecture on S4 physics. As I mentioned you before, the topics which we discussed in our all section, and today's our lecture number first. And in today's lecture, we will basically discuss about the speed, distance, and time. Okay.
Mm-hmm.
So here are the basic table of content what we supposed to do in our today's lecture. First of all, we will see what are the learning objectives. Then we will discuss what is basically the motion. And there are some types of motions we will discuss, like there are two types of quantities, either scalar or vector. And then we will move on towards the key physical quantities, and we have some practical work examples for these topics we will do in today's lecture, and then we will forward on towards a new topic which is average speed, and
Mm-hmm.
then we have a practice quiz for you, and the important topic for today's lecture is the unit conversion. We will discuss how we can convert the conversion if you want to convert from kilometer per hour to meter per second, or meter per second to kilometer per hour. This is very important conversion in physics. And at last we have some short homework for you as an assessment. Okay.
Mm-hmm.
Okay, so here are basically the learning objectives. So in this today's lecture, basically we will describe what is motion. I already mentioned you before what's the definition of motion. We will also discuss it later in today's lecture. We have some basic quantities. In motion, we have some basic quantities like distance, speed, and time. And then we will apply some formula for speed. We know the formula for speed, and we can also say it as the velocity. So the formula for speed we will discuss is speed, which is denoted by small v, and the formula is v equals to d by t, where d is the distance and t is the time. So rate of change of distance is basically the speed. Okay, so this formula is basically for calculating the speed. Okay,
Mm-hmm.
and then we will move on towards different quantities. We will discuss scalar as well as vector quantities. What are scalar quantities and vector quantities? And then we will solve some problems related to average speed. First we will know how about what is speed, and then we will discuss what is average speed, and we will discuss some their problems. And at least we will see how we can convert units like kilometer per hour to meter per second, or we can also convert meter per second to kilometer per hour. So basically here is the basically the introduction of S for physics. So for that, as I already mentioned you before, what is physics? That physics is basically a branch of science, okay, in which we will deals with the study of matter, energy, and their interaction. As you know that everything in the universe are made up of matter, right?
Mm-hmm.
So everything in the universe made up of atoms. An atom is basically a matter. And what's the definition of matter is that anything that occupies space and have some weight. So in our physical universe, every object has some mass. There is no any object which has no mass. And a body which having mass, they must occupy some space. Okay, so a body which has some mass and that is occupying some space, we can say that is a matter. And everything in the universe are made up of matter. And when one matter interacts with another matter, they release some amount of energy. So relationship between matter, energy, and interaction, we can say this is so called as the physics. Okay, it helps us to understand how and why things move, okay, and how energy flow, how light travels, how the universe behaves, from tiny atoms to the massive galaxies. So this is all we discuss in the physics, okay. Why physics is so important? Because we have to explain some real life situations, like we have to answer the questions like why do we wear seat belts while driving? You know that we have to wear seat belts, but why we have to wear that seat belts? So this could be answered by physics. How does a phone works? So phone is working behind physics. Help develop problem solving and thinking skills. Foundation of many careers. Physics is basically also the basic careers in engineering, medicines, technology, and research. So we cannot forget physics. Physics is everywhere in the universe. Okay. Okay, what you will learn in astrophysics, these are the main topics, and I also mentioned you in our previous class. Like we have to discuss first of all some types of motions, their forces, speed, and energy. And in next chapter we have to learn about light, sound, waves, and radiations. And then we have to discuss about electricity, heat, and the environment. And at last, we have some real world applications and scientific thinkings. So this is all we will discuss in S4 physics. These are the main topics, main chapters for S4 level. Okay, this class basically what our class is basically 50 to 60 minutes. We will basically visual explanations and we will solve some real examples. We have 101 interactive quizzes and a regular homework for you as an assessment and which helps you, okay. And our goal is to basically build the understanding, not just memorizing, because physics is all about the understanding, okay. And
Mm-hmm.
you must have to ask questions, okay.
Mm-hmm.
Basically you are preparing for national 5 exam, right?
Mm-hmm. Yeah.
Which is in June, July 2026.
Uh, I think it's May.
Okay,
May.
May. Okay, May 2026. Okay. Okay. So basically, here's the motivation for you is that physics help us to understand the world, okay? From why a rainbow appears to how rocket reaches the space. It's not about memorizing, it's all about asking questions. So be curious and you have to ask questions. Every concept matters, okay? Hmm. So let's start. Our today's first topic is we have to discuss about what is motion. So can you explain a bit about motion? What is a motion?
Uh, something that moves, or how
Yes,
something moves.
yes, something that moves. Okay, you're right. Basically, motion is that something that moves, or if something changes their position, okay, from one point to another. If you are sitting on a table and you change your position and went out of your room, so you change your position and also time changes. Okay, time changes or
Hmm.
not?
Yeah.
Yes, time never stops, time changes. So change in position with respect to the time, we can say this is basically the motion. Okay, so how we can define motion is a change in position over time. So by changing position with respect to time, you possess motion. Practical example is that a car on the road. A car is moving on the road. So if a car is moving on the road, so either it's changing its position or not.
Uh, it's changing its position.
Uh, yes, because the car is moving, so it's continuously changes their position. So if they changes their position continuously, so we can say that the car is in motion. Okay. So if the car is not moving,
Hmm.
so either they are in motion or not.
Not in motion.
Yes, they are not in motion. So if they are not in motion, so what we can say they are in
Uh,
rest
mm,
position.
sorry.
Rest position.
Right.
Okay. So if a body
Hmm.
is not moving, we can say the body is at rest position. Okay. Understood?
Yeah. Yeah.
Okay. So we have some other example like if a ball is falling from some height. So if a ball is falling from some height, they continuously changes their position. So we can say the ball is at in motion. Also, we have an example of spinning fan. The fan is spinning. They continuously changes their direction, their you can say position. So we can say the fan is in motion. Okay, and in motion we have further three types of motion, and the first one we can say is the linear motion. Okay, what is
Hmm.
basically the linear motion is if a body is moving in a straight line, they are not changing their path. If a body is moving in straight path, we can say the motion is a linear motion. Okay, let's
Hmm.
take an example like a car on a road. If a car is moving in a straight line, you can say from this example, if it is moving in a straight line, not taking any turn. If this car takes a turn, then this car will not be in linear motion.
Hmm.
The key concept is the car must be have in straight line motion, not changes their turn. Okay, and the other type of motion is that circular motion. If a body is moving in a circle, so we can say this type of motion is called as the circular motion. Like this fan is moving, rotating, circulating about their axis. So we can say this type of motion is called as the circular motion. Okay,
Hmm.
and we have some other type of motion like oscillatory motion. Oscillatory motion basically means if a body changes their position to and fro, front and back. Okay, so like
Hmm.
you can see this this swing will either go back or front. Okay, so this to
Hmm.
and fro type of motion basically called as the oscillatory motion. So these three are basically the types of motion which is important. Okay, linear motion if a body is moving in a straight line, circular motion if a body is moving in a circle, and oscillatory motion if a body is moving to and fro. Okay, understood?
Hmm.
Okay, now move on towards next topic, which is the scalar and vector. Uh, you
Hmm.
know somehow about scalar and vector. Are you understood? We discussed this
Yeah.
topic in the previous class. Can you explain me a bit about What are scalars and vectors?
Scalars are quantity that only hold size, and vectors hold size and direction.
Yes, size and direction as well. So you're right. Basically, the scalar quantities are those quantities which have only magnitude. Okay,
Mm-hmm.
not the direction. Like you told me that some of the examples like speed has some value. Like a car is moving with 50 kilometer per second speed or 50 kilometer per hour speed. So basically the value, the magnitude is 50. Okay, but we cannot specify the direction for speed. And also like time, either time is 5 o'clock or 6 o'clock. So 5 or 6 is basically their magnitude, but time has no direction. Okay,
Mm-hmm.
as well as the vector quantities, it has magnitude as well as direction both. Like velocity, a car is moving with velocity of 10 meter per second. It means 10 is their magnitude. Okay, and car is moving in some direction, either in forward direction, backward direction, right or left, right? So
Mm-hmm.
if this has some direction, so we can say this is a vector quantity. So velocity is a vector quantity. Also force must be apply in some direction. Either you apply force forward or either backward. So if you are applying force in some direction, so we can say force is a vector quantity. Understood?
Mm-hmm.
All set. So here you can see the illustration like time, which has only magnitude. Okay, not the direction, as well as you can see the speed. Speed is also a scalar quantity. Also the temperature is also a scalar quantity because it has only magnitude. Either the temperature is 20 degrees Celsius, 30 degrees Celsius. So temperature is basically a scalar quantity. Temperature has no direction, and whereas the vector quantity having magnitude as well as direction, and vector quantities are denoted by this arrowhead.
Mm-hmm.
Okay, this arrowhead you must have to apply. If some quantity is a vector quantity, so you have to apply this arrowhead above. Okay,
Mm-hmm.
this arrowhead basically specifies the direction, either right or left, up or down.
Mm-hmm.
So clear?
Mm-hmm. Yeah.
Okay, sounds good. Now move on towards next concept, which is about distance. Distance, time, and speed. We have to discuss the relationship between distance, time, and speed. A distance which is denoted by small d, time which is denoted by small t, and speed which we can denote by small v. Okay, so how we can define the distance is that how far something moves. Okay, how far your body moves. The distance they cover is basically specifies that the distance. Okay,
Mm-hmm.
and the distance is basically a quantity we can measure in. Can you tell me how we can measure distance, or in what unit we can measure the distance?
Meters,
Yes,
kilometers, and
yes,
miles.
yes. If our distance is small, so we can measure in meters. If this is a large distance, so we can measure in kilometers. So
Mm-hmm.
basically, can you tell me what is kilo means?
Kilo means 100 or a
Uh,
thousand.
Kilo means 100 or 1000.
I think it means 1,000.
Yes, kilo means 1000.
Mm-hmm.
Okay, so everything that basically how you can say how far your body moves. So we can say they cover the distance, and distance can be measured in meters. And how can you define the time? Basically, how long it takes. If a body is moving, how long it takes means how long means how much time it will takes. Understood? And
Mm-hmm.
how can we measure time? What's the unit of time? Do you know?
Seconds, hours, minutes.
Yes. So the unit of time is seconds. The SI unit, System International Unit, is seconds. And what is basically the speed? Speed is basically the rate of motion. If a body is in motion, then there is some value of speed. If a body is not in motion, you can say if a body is at rest position, then the speed is zero, right?
Mhm.
So if a body is in motion, so we can say they must have some speed. Okay, and that speed is denoted by small v. And the formula for speed we will discuss here. And speed is a quantity which can measured in this unit. And this unit is so called as the meter per second. Keep remember this unit. Okay. So we can measure
Mhm.
speed or you can also say it as velocity. Okay.
Mhm.
Speed can be measured in meter per second. So let's discuss the formula for speed. How can we calculate the speed if we know about the distance and time? So if we know the distance and time, we can easily measure the speed. So how we can find? So we have a formula for finding the speed is that v equals to d by t, where v is the speed, t is the distance, and this small t is basically the time. So speed equals to distance by time. Okay,
Mhm.
let's now solve some practical examples for finding speed. Are you ready?
Mhm.
Okay. So if a car, let's suppose moving if a car basically moves and it covers a distance of 200 meters in 40 seconds, can you find
Mhm.
their speed?
Uh, 5 meters per second.
Yes, 5 meter per second. How it comes?
Because 200 meters over 40 seconds
Yes.
would be.
Uh, Oh, yes. Basically, distance is given, which is 200 meters. A car travels
Mhm.
200-meter distance, and also they covered this distance in 40 seconds. The time is also mentioned. So, if distance and time both are mentioned, we know the formula of speed, which is distance by time. Just divide the value of distance over time, we will get their speed.
Mhm.
So the answer is 5, and we know the unit of speed is meter per second. So answer is 5 meter per second, right?
Mhm.
Perfect. So another example is a person cycles for 15 seconds. Okay? Means a person
Mhm.
is cycling and they cycle for just 15 seconds. So basically this 15 seconds is basically the time. So the time is mentioned at 6 meter per
Mhm.
second. And this 6 meter per second is basically their speed. Can you find distance?
90 meters.
Yes, 90 meters. How it comes?
Because 15 seconds times by 6 meters per second.
Hmm, fine. Basically, the time is given now, and now the speed is given. They are asking to find the distance. So basically, this the value of v is given, which is 6 meter per second, and the value of t is also given, which is 15 seconds. And they are
Mhm.
asking to find this small d. If you want to find small d, what you have to do, you have to multiply this d to the other side. Am I right?
Mhm.
So if you want to find only this d, you have to move this d, which is in denominator, you have to move this d to the other side and multiply it by small v. So d becomes equal to v cross t, right? D becomes equal to
Mhm.
V cross T. And the value of V is given, which is 6 meter per second. You can put here, and the value of time is 15 seconds. So 6 multiplied by 15, it becomes 90. So the distance is 90. And we know what is the unit of distance, how we can measure distance in meters. So the correct answer is 90 meters.
Mhm.
Okay, all set?
Yeah.
Okay, now let's discuss basically how to find the average speed. Okay,
Right.
basically average. Do you know what is meant by average?
Uh, the most frequently seen speed.
Yes, the most frequently, or you can say the total speed.
Mm.
Okay, the subtotal speed. So how we can find the average speed is basically the formula is same because you know the what is the formula of speed. Speed formula is distance by time. Am I right? Yes.
Yeah.
If you are finding average speed, so formula changes into total distance divided by total time. Noted?
Yeah.
Okay, so here as an example for you, if a car travels some distance 1 in 200 meters and it takes time in 40 seconds, and again it travels and again it covers a distance of 100 meters and now it takes 20 seconds. Now they're asking to find the total distance. Means same
Mm.
car is traveled two times. One times it covers 200 meters distance, second times it covers 100-meter distance. First time it takes 40 seconds and second times it takes 20 seconds. They are asking to find the average speed, and average speed is denoted by this v, which is the speed, and in subscript we can write avg, okay,
Mm-hmm.
for the notation of average speed. So how can we find? We know the formula for speed, which is distance by time, but we are doing average speed. So we need total distance divided by total time. So first distance is 200 meters and second distance is 100 meters. So what should be the total distance?
Uh, five,
Uh,
5 meters per second.
5 meter per second is basically the average speed. I'm asking about what is the total distance that the car covered. First time it covers
Uh,
200 meters and second time it covers 100 meters.
oh, 300 meters.
Yes.
Sorry.
So the total distance that the car cover is 300 meters. And what's the
Mhm.
total time it takes?
60 seconds.
Yes, 60 seconds because 40 plus 20 it becomes 60. And the formula is same, just divide your distance with time, you will get the speed. Okay,
Mm-hmm.
and the unit is in meter per second because we know speed can be measured in meter per second.
Mm-hmm.
How
Yeah.
we know it measured in meter per second? Because you can see in numerator its distance, and distance is denoted by measured in meters, and in denominator you can see its time, and time measured in seconds. So here is meter and in denominator is seconds. So it becomes meter per second.
Mm-hmm.
Okay, now it's some practice quiz for you. So can you calculate it for me? Calculate the speed. If distance is 300 meters and time is 60 seconds.
Mm-hmm. Should I just answer whenever I get it? Or
Are you finding?
yeah, I found it.
You have to calculate the speed if distance is 300 meters and time is 60
Mm.
seconds.
It's 5 meters per second.
Okay, 5 meter per second. How you solve it?
Um, well, I put the distance over the time and I divided them.
Uh, Wonderful. Okay, next question. How far do you travel? What does it means? How far do you travel? Basically, it asking for to find.
The distance.
Uh, yes, you're right. Basically, it's they're asking to find the distance. Uh, so if the speed is given 4 meter per second and also the time is given, which is
25
second.
seconds.
So find distance and let me know what's the value of distance.
Is it 100 meters?
Oh, yes, you're right, 100 meters. How you find it?
Well, I just times 4 by 25 seconds to find the distance.
Oh, yes, perfect. So the third one is if a car drives 150 meters, means distance is given in 25 seconds. Also, the time is given. Can you find their speed?
Yeah. Is it 6 meters per second?
Meter per second. How you did it?
Uh, 150 divided by 25.
All right, sounds good. Okay, now move on towards the unit conversion.
Mm-hmm.
Okay, so basically in unit conversion, we have to discuss two types of conversion. How can we convert an important conversion kilometer per hour to meter per second, and how can we convert meter per second to kilometer per hour. So first let's check out how we can convert kilometer per hour into meter per second. Okay, so if you want to convert some value that was in kilometer per hour and you have to convert it into meter per second, how can you do? The concept is that you just have to multiply it by 1000 and divide it by 3600. Okay,
Mm-hmm.
how this concept basically arises, because you know that this kilo means 1000,
Mm-hmm.
that's why this 1000 you have to multiply it by 1000. And this hour, in 1 hour, can you tell me how many seconds are there?
Um,
In 1 minute, how many seconds are there?
60 seconds.
Yes. So in 1 hour, how many seconds are there? In 1 hour,
Uh,
basically there are 60 minutes, and 1 minute have 60 seconds.
yeah.
So if you want to calculate number of seconds in 1 hour, you just have to multiply 60 multiply by 60. So 60 multiplied by 60, you will get
6,600.
3600. Okay,
600. Mm-hmm.
got it?
Yeah.
So these are the seconds in 1 hour. So 1 hour have 3600 seconds.
Mm-hmm.
If you want to convert any number that was in kilometer per hour and you have to convert it into meter per second, you have to multiply that number by 100 by 1000 and divide it by 3600. Understood?
Mm.
Okay.
Yeah.
Here is a practical example. Uh, Convert 2072 kilometer per hour into meter per second.
Um,
Can you convert 72 kilometer per hour into meter per second?
yes.
Please calculate and let me know. What you have to do is simple multiply that number which is 72 multiplied by 1000, which
Divided by
I mentioned
2000.
you before, and divide it by 3600. So 72 multiplied by 1000 divided by 3600. So you will get your answer. So do you have a calculator?
Yeah.
So solve it and let me know the answer for that.
20.
20.
20 meters per second.
Okay, 20 meter per second. You're right. Understood?
Yeah.
Okay, so you can also say it in simples, like you just have to divide your number by 3.6 because this remains constant always. 1000 divided by 3600. So you can do this concept, or you can also do this concept like just divide your number by 3.6. You can also cross check. Divide 72 by 3.6. What should be the answer?
20.
Yes, same 20. So if you want to convert your kilometer per hour to meter per second, just do this step or just divide your number by 3.6. All
Mm-hmm.
right. And if you want to convert the opposite, if you want to convert from meter per second to kilometer per hour, like say, so just you have to do inverse thing here. Just now multiply by 3600 and now divide it by 1000. Okay,
Mm-hmm.
because now you're moving back. Now you have to convert meter per second to kilometer per hour. So if you are doing this, so what you have to do now, you have to multiply by 3600 and divide it by 1000. So practical
Mm-hmm.
example is that convert 10 meter per second into kilometer per hour. Can you tell me?
Yeah. Second. Sorry. Sorry, what was your question again?
Now you have to convert 10 meter per second into kilometer per hour.
Uh, would it be
You just have to
36 kilometers?
multiply that number by 3600 and divide it by 1000. So it becomes 10 multiplied by 3600 divided by 1000. Or you
Right.
can do the simple step, just have to multiply your number by 3.6. You can also go the same answer. There are two methods to solve to convert. Just multiply your number by 3.6. So if the number is 10, which you have to convert, just multiply it by 3.6, you will get your answer.
Uh,
So 10 multiplied by 3.6,
36 kilometers per hour.
no, 36 kilometer per hour. So this is how you can convert. So if you want to convert kilometer per hour into meter per second, you have to divide by 3.6. And if you have to convert meter per second into kilometer per hour, you have to multiply it by 3.6. All right.
Mm-hmm.
Basically, do you know which speed the light travels?
So, 300 million meters per second.
All right. So yes. So the light speed at this speed, 300 million kilometers meter per second. Okay, and it takes 8 minutes to reach the Earth.
Mm-hmm.
So if this is the speed of the light, and if it takes 8 minutes to coming from Sun to the Earth, can you find the distance?
Yeah.
Yes, because we know the formula of distance. Distance equals to speed multiplied by time. So just
Mm-hmm.
multiply the value of speed, which is 300 million meter per second, multiplied by time. Okay. Now the time is 8 minutes, not in seconds. Firstly, you have to convert 8 minutes into seconds. You know, 1 minute has 60 seconds. You have to convert it. If you want to convert 8 minutes into seconds, what you have to do is just multiply 8 by 60. So 8 multiplied by 60, what should be the answer?
480.
So 400 seconds. So just multiply 400 by 300 million, you will get the distance between Earth and Sun, right?
Yeah.
Okay. So here are some rapid questions for you. Can you tell me what is the formula of speed?
Uh, Speed is distance over time.
Okay, right. So can you tell me speed is a scalar or a vector?
Vector.
Oh,
No,
yes.
scalar.
Yes,
Scalar.
it's a scalar. Scalar. Okay. So can you convert 54 kilometer per hour to meter per second?
Yeah.
Let me know the answer. Uh,
15 meters per second.
yes, you're right. 15 meter per second. You're right. So here are some homework assessment for you. Okay, you can do, and you can solve these questions